So the question we have here from the periodicity test is outline 2 reasons why a sodium ion has a smaller radius than a sodium atom. So when we think of sodium, we know that it has 11 protons and 11 electrons. And one of the most common ions of sodium is Na+, in that they have 11 protons still, but they've lost an electron. And now because of this, Na+ has a greater net positive charge because there are more protons present than there are electrons. So already this has a greater charge than this would. And that automatically means that because of the less electrons, it's going to have a greater pull on the electrons that are present because there's one less, so the attraction is greater. And thus, it's going to pull in the electrons in from outside, which makes the radius just that little bit smaller, even if it's not significant, but it's just enough to make it smaller. So that's for the 2 marks there. And now for another, I think this was 2 marks as well, didn't write that down, whoops. The second part of the question was, explain why the ionic radius of P3- is greater than Si4+. So we know that phosphorus as itself is has 15 protons and 15 electrons, and silicon as an atom again has 14 protons and electrons. But here we know that in phosphorus 3-, it's gaining 3 electrons, and in Si4+, in silicon 4+, it's losing 4 electrons. So silicon then is down to 10 electrons and 2 energy levels. In this diagram, we can see that at the start, with the red crosses as well, this is what silicon would be like. And then when we remove the 4 electrons, we can see that it goes down to only 2 shells instead of 3. So that's going to be smaller in its radius. Whereas in P3-, it gains the 3 electrons, which helps to fill the outer shell of the 3rd shell. And because of this, they have 18 electrons and 3 energy levels, which then increases the radius because instead of having 1 less shell, it has 1 more, thus making it bigger. And so that's all you had to explain for the 2 marks there.